Hi all, this is Priyadharshini working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to deal into the topic the process concepts. So let us see about the process concept. Before going into the process concept, let's see the objectives of the process. So as we all know, the notion of a process is a program and execution which forms the basis of all the computation process, and also to describe the various features involved in processes, including the scheduling criterions, the creation and termination and the communication between processes. Also, we'll explore about inter-process communication using shared memory and message passing systems, and also to describe the communication in client-server systems. So what is a process? So process is nothing but it is a passive entity stored on disk, which is an executable file. So as we all know, process is a program and execution. When we all know what is a program. So program is nothing but the set of instructions. When the set of instructions is stored, it will be stored in the secondary disk. That is in the stored, it will be the secondary disk. And then when it is compiled, it is again stored in the secondary disk. Once the program is ready for execution, then it becomes a process. So a program is a passive entity stored on disk, that is your secondary disk. Then when it is ready for execution, it becomes process. So program is passive entity, whereas a process is an active entity. So program becomes process when executable file loaded into main memory. The execution of program starts via guide, mouse clicks, command line entry of its name, etc. So you can use any of the interfaces available. One program can be several processes. Consider multiple users executing the same program. So this is the process, how it will be in the memory segment. So in the lowest level, we have the text segment. So the text segment contains the actual executable code. So it is stored in the lower part of the memory because no actionable insights will be taken thereafter while running the program. And then you have the data section. In this data section, you have the global and static variables that is written by the programmer. Then you have heap. So here in heap, the dynamically memory allocated variables will be stored in the heap section, and then in the stack section you will have the local variables, your functions, your parameters, call by value, all the references will be stored in the stack value. So this is about the process thing. So a process is a program in execution. This process memory is divided into 4 sections for the efficient working. So as I told you before, the text section is made up of the compiled program code written from non-volatile storage when the program is launched. Data section is made up of global and static variables allocated and initialized prior to executing the main program. The heap is used for dynamic memory allocation and is managed via calls like your system calls like malloc, realloc, delete, new, free, etc. The stack is used for local variables. Space on stack is reserved for local variables when they are declared. So both heap and stack are different in nature. So it will vary from process to process. As we all know what is the definition of the process, we will move to the different states of a process. So as a process executes, it changes its state. So first state is new, that is new state, the process is being created, running, instructions are being executed, waiting, the process is waiting for some event to occur, ready, the process is waiting to be assigned to a processor, terminated, the process has finished its execution. So we will have a detailed look in the process state. So when a program becomes a process, that is when it is loaded into the main memory, the process is created, that is the new state. So it is then allocated to the processor. So when the process is allocated to a processor, it moves to the running state. So in running state, and The ready state is nothing but when the process is ready for its execution, only then the processor is not available for execution. Otherwise, all the other instructions are executable and they are in ready state. The next state is running. So when the process is from the ready state, when it is given the CPU, that is the processor, it moves to the running state. So when the running, if so, from the new state to ready state to running state, if there is a smooth transition and if the process is loaded properly and it has been executed softly, then it will go to the section called the terminated section, that is the exit section. When suppose there occurs another thing, suppose if the running process needs some input output, then it will be waiting for the input output resources, so it will be sent to the waiting state, and after the input output devices are being given and it has been processed with all those things, then again it will be given to the ready state. Suppose if there is any interrupt occurs also, the running process will move into the ready state, and after that the scheduler will be dispatching again the process to the processor, then finally it goes to the terminated state. So these are the 5 states available in the process.